Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Part 6 of Advanced Threat Tactics, Lateral Movement. In this lecture, we're going to go through how to expand from our foothold, elevate our rights in the domain, and take over the network. We're going to introduce concepts around Windows Enterprise networks and vocabulary. We'll then spend some time talking about host and user enumeration. And just to make sure it's very clear, we'll talk about options to operate against the target and interact with it without using any malware at all. We'll then talk about all kinds of different trust material and how to repurpose that trust material into a trust relationship that you can use to attack a target. And we'll talk about how to use that trust relationship to get remote code execution on a target. Let's start with the Windows Enterprise. Active Directory is a collection of technologies to allow central management of users, systems, and policies. Okay? A concept within Active Directory is the concept of a domain. A domain is both an administrative and technical boundary where users and systems are managed with Active Directory technologies. Within a domain are a few central servers that act as the broker of trust for that domain. Those central servers are the domain controllers. Those are systems that authenticate users and systems on the domain. A local user. A local user is a standalone account on a system, okay? When we specify a local user account on the Windows command line or with Cobalt Strike's automation, we do it either as a computer name / the user, and by computer name I mean the NetBIOS name, or we do it with a period for the computer name, which is a placeholder or wildcard for that computer name / the user. A domain user. A domain user is a user account on the domain controllers, okay? And these accounts are specified as the domain name / the user, okay? A local administrator. A local administrator is a user with administrator rights on a system, okay? So a local user could be, a local administrator could be a domain user or a local user. It doesn't matter. But as far as that system is concerned, that user can do things. A domain administrator. A domain administrator is a user with administrator rights on the domain controller. A domain administrator is also a local administrator for everything in the domain. Okay. When it comes to enumeration, there's a few questions you want to ask when you have a foothold in the network, okay? First and foremost, you want to know which domain am I on, okay? You want to know what domain you're dealing with. That's very important. But domains don't usually exist in isolation in a big enterprise. They usually belong to a forest with a whole multitude of different types of trust relationships. So the next thing you want to know are what are the domain trust relationships, okay? The next thing you want to know is for these domains that you can reach out and touch, which systems are in these domains? What are your targets? What can you touch? And also, just because it's where the data lives and you might not even need to elevate, it's very helpful to find out which shares are on these systems because that might be your opportunity to just get the data you need, pull it out, and say mission accomplished. Let's go through a few enumeration commands. Here are a few Windows commands to answer many of these questions. NetView whack domain will tell you what the primary domain you're on in your current context. Okay? You can do NetView whack domain : the domain name to get a list of hosts in that domain. And it's not going to be every host, but what it is, it's basically the network neighborhood view if you've ever clicked that icon on a Windows desktop. You can also do netgroup domain computers whack domain to get a list of the computer accounts for systems joined to the domain. And these computer account names map very well to the NetBIOS names of systems joined to the domain. Now, if you want to find out which hosts are the domain controllers for the domain, you can use the nltest command. Just do nltest whack DC list and the domain name. Okay, cool, cool. Oftentimes in Cobalt Strike, you will interact with a target just by its NetBIOS name. Okay, you don't really care if it's an IPv4 address. You don't really care if it's IPv6. NetBIOS names and fully qualified domain names are, in my opinion, the way to go. But if you want to translate a NetBIOS name to an IPv4 address, you can do it with NSLOOKUP, or you can use ping to send one packet to that host and get back the IP address that way as well. Now, if you want to map domain trust, you can use the nltest command to do so. So just do nltest whack domain_trust. Next, if you want to list shares on a host, just do netview backwhack NetBIOS name of a target to get a list of shares on that host as well. Okay, let's do some target enumeration a couple of different ways. We'll do it the Windows command line way, we'll do it with PowerView, and we'll do it with Beacon's net module. Let's start out by figuring out which domain we're on. Okay, we're on the Playland domain. Cool. Let's find out where the domain controller is in the Playland domain. So we'll just do an nltest whack DC list Playland. The command is going to fail because we are a 32-bit payload on a 64-bit system and nltest is not in our path. So what we need to do is specify cwindows sysnative, that is the real system 32 on this 64-bit system, and just do whack DC list Playland. And there we go. The DC is at dc.playland.testlab. Very cool. And by DC, I mean domain controller. Let's try a couple other things. Let's try to figure out some targets. Let's do a netview whack domain Playland. And this is going to give us that network neighborhood view. And if we want more, we can find the computer accounts of systems joined to the domain by just doing a net group domain computers whack domain. And there's the computer accounts of the different systems joined to this domain. So that's enumeration of targets on the Windows command line. Something you should become very familiar with, though, is a PowerShell script called PowerView. PowerView is also written by Will Schrader. Okay? PowerView is a network situational awareness tool written in PowerShell. Here's a few commandlets in PowerView to know. Invoke netview will find machines on the local domain. Okay? Invoke sharefinder will find non-standard shares on the network. And invoke map domain trust will find all trusts for the current domain. If you want to run these, just do PowerShell import the local path to PowerView.ps1 and use PowerShell, whatever commandlet and arguments you want to run these commands. Now let's do things the PowerView way. We'll just do PowerShell import and we'll bring in, it's under Power Tools, PowerView, PowerView.ps1. And let's do PowerView invoke netview. Okay? And this should give us back the same information, roughly, as our netview whack domain. And by roughly, I mean that and a bit more. So here, it can see information about the system we're currently on, Climber, and which accounts are logged on to it. Same with the file server as well, and the domain controller. Okay, so a bunch of information about these different systems. And it also tells us which systems are the domain controllers as well. So that's a little bit of a target enumeration with PowerView. Cobalt Strike includes its own net module, and the net module is a beacon post-exploitation module that provides commands that map to the Windows Network Management Functions API. To use the net module, you just type net in the beacon console, and then whatever command you want it to execute. So you can do net DC list to get a list of domain controllers for the current domain, or net DC list to get a list of domain controllers for another domain. Okay? You can do net share // target to list shares on the target. And you can do net view or net view // in the domain name to list hosts on the domain. The output of these commands is very, very similar to what you get from the native net commands, but it's a little bit different. The syntax is also a little bit different as well. Now, let me show you the net module in Beacon. Let's just do net DC list. And there we go. There's the DC for Playland. And we can just do net view. And the net module's view command will give us the same output as shell net view, but it will also get the IP address of the target, and it will tell us which version of Windows it's running, and the comment for that system as well. Also, this information will go into Cobalt Strike's host data model as well. So if we come over here to the targets thing, we can see the DC and file server are there now. Okay, so by this point, we've done some host and trust enumeration. We have an idea of which domain we're on, and we know about the domain controllers, and we know where some targets are. Cool. Now, let's talk about user enumeration. Here are the questions I think are pretty important. You want to know where your current user or trust relationship that you've set up is an administrator, okay? That's something important to know. You also want to know which accounts are the domain administrators. Finally, for systems that you want to target, you want to know who are the local administrators on those systems, because you may be able to get a hold of a trust that lets you impersonate that user to that system and get access to it. Okay? So these three questions are the point of these user enumeration steps. First, let's talk about administrator accounts. Administrator trusts, whether it's a local administrator for one system or a domain administrator for all of them. These trust relationships allow us to do things to systems. We can interact with administrator-only shares, we can schedule processes, we can do a lot of really, really cool stuff. In a Windows command shell or in Beacon, if you want to find out if you're an admin, one way to do it is to try to list an admin-only share. Just do a dir, like shell dir, // host, $C$. If you get a directory listing, you're probably a local admin as far as that system is concerned. You can also do something like using @ to dump a list of jobs on a system. If you get back access denied, probably not a local admin. If you get back a list of jobs, you're probably a local admin. Okay? PowerView has some really nice automation to help out with this question. You can do PowerShell, invoke find local admin access after you import PowerView, and PowerView will sweep the network and try to hit, I think it's the pipe for the Service Control Manager, and if it can open that, it will come back and say, hey, you're a local admin as far as that system is concerned. And that's a trust relationship we can act on. Okay, let's do a little bit of trust enumeration and figure out where the current user might be a local admin. So first, the way I check if I'm an admin somewhere, I just do a dir // target $C$. And if I get an access denied, no joy. Okay? So let's try the same thing with file server. And you'll see I get a listing. That means, according to the file server, the user JSmith, the domain user JSmith, must be a local administrator. So you can go through your different options by hand and see where you might be an admin. Another option is to use Power View and do invoke find local admin access to get a little bit of automation to help you out. And there we go. Power View is telling us the same thing we already knew, and that is we are a local admin on file server. Okay, let's go on with our other questions. Let's say we want to figure out who the domain administrators are. Well, you can use the native Windows commands in a shell: net group enterprise admins, whack domain, net group domain admins, whack domain, to find out who are the members of these domain groups. Or you can do net local group administrators, whack domain, to see who is an administrator on the domain controller. Okay? Beacon's net module can help with this as well. Just do net group // target. By target, I mean one of the domain controllers, and do whatever group name you want to look at. So enterprise admins, domain admin, domain admins, so on and so forth. You can also do net local group, a target, and a group name. And this could actually be any target to get a list of who's in the. Now, let's go ahead and just do some account reconnaissance and do what I was talking about before, which is checking who might be a domain admin. We can do that with net group, enterprise admins, whack domain, and we can see the user administrator. Try the same thing in the domain admins group, and we can do net local group administrators on the domain controller. And we see that the user lab on that system must be a domain admin as well, and of course the user administrator. Local administrators may be a domain account, okay? That's really important to know. So if you want to attack a system, you should find out who are the local administrators for that system, because if you can get a hold of password hashes for them, get a hold of credentials or a token, you can impersonate that user and leverage that trust to interact with that remote system. So Beacon's net module can query local groups and users on a system from an unprivileged context. Just do net local group // target in a Beacon console, and you'll get a list of groups on target. Now, if you want to get a list of members of the group, just do net local group // target, the group name, to get a list of members of that group. These commands were inspired by Power View because Will Schrader is the one who informed me that it was possible to query local groups from an unprivileged context. And Power View does it really, really well. You can do Power View do get net local group -hostname, the target, to query the local administrators on the host. And this command will actually recursively go through the administrators group, find all the subgroups, and report the members to you. And you can use Power View to find the same information on every host. You can do invoke, enumerate local admins. Just remember to prefix those two commands with the PowerShell command. And I mentioned you can use the net module in Beacon to query local groups and users on a system. So let's say the file server is our target. And big surprise, we already know we are a local admin on the file server. But here's how I'd query the groups on the file server. I would just do net local group file server from Beacon. And we get back a list of groups, okay? And I could do net local group administrators to see who is in the administrators group on the file server. And this action does not require any type of special privilege. And we can see that the lab and administrator users are local admins on the file server. Anybody in the domain admins group is a local admin, plus all these different domain users. Pretty cool. So that's the net module way of querying who might be a local admin. Let's try it the Power View way. So let's do Power View get net local group dash hostname, and we'll do on the file server. And there we go. Now we have some information, quite a bit, about each administrator user on the file server. Again, the really neat thing about Power View is the Power View way will recursively go through all the different groups and find information about which users are in each group, so you have a full picture without a lot of legwork. Okay, let's say we found a system that trusts us as a local administrator. Cool. What kind of stuff can we do to that system? Well, we can interact with admin-only shares to interrogate the system. So for example, if I do a dir // host / $C$, which is a share for C:// I can see what's on their C drive, okay? And if I want to, I can copy a file back over a UNC path as well, okay? Just do copy, // that host, $C$, foo, whatever file, and bring it to the current system I'm on. I can also build up a shopping list of files on that remote host by doing what's called a dir walk. I just do dir /s/b, // host, / $C$, put that information to a local file, pull it down, and go shopping. Here's something else that's pretty cool. You can use WinRM, which runs on port 5985, to run commands with PowerShell. WinRM is the Windows Remote Management Service. It is not on by default, but many organizations that have embraced PowerShell do turn it on key servers to make remote administration much, much easier. To use WinRM to run a command on a target, just do PowerShell in beacon, invoke command, computer name, put in the target, -script block, and then inside of curly braces, whatever you want it to run. And what will happen is this will task that system via WinRM to run that command, and it will report the output back to you. So you can use PowerShell and invoke command as a remote access tool to control a system without putting any malware on it whatsoever. It goes further though. You can use PowerSploit to run Mimikatz over WinRM. Just do PowerShell import path2 invoke mimikatz.ps1 from PowerSploit, and then just do PowerShell invoke mimikatz -computer name and put in the target. Okay, let's demonstrate some of the capability to interrogate a target without using malware. We already know that we can list the C drive on the file server. Well, we can also do things like do a dir walk if we want. Let's do a dir walk on // file server, $C$ users, to get a list of the files in the different user folders. Okay, so there might be something useful for us to go through there. So that's pretty cool. And of course, we could copy files over and exfil them without ever actually putting malware on that box. But a few moments ago, I also mentioned you could use WinRM with PowerShell's invoke command commandlet to run commands on a target and get output back. Let's try that. Let's do PowerShell invoke command, and we'll do computer name, file server, script block, and whatever we want to run within these squiggly brackets. So there's a dir on C://. Okay. If I want to, I can do net local group administrators. And there's our output for that. Same thing we were able to pull with Power View and with the net module and beacon. Okay. So the main lesson here is that with WinRM, we can run whatever command we want on the target and get output back. Pretty cool. But now let's take a look at using PowerSploit to run Mimikatz on that server. So let's do PowerShell import. And let's do PowerSploit, exfiltration, invoke, not that one, invoke mimikatz.ps1. Let's do PowerShell, invoke mimikatz, -computer name, the file server. And this option will by default run logon passwords on the file server. So now we can go through the output and see if there are any creds of interest, such as maybe the password of a domain administrator account. So that's an example of using PowerSploit to run Mimikatz on a remote system without putting malware on it. Okay, now that we've gone through all of that, let's talk about trust material and trust relationships, okay? So far, we've understood this idea that if you're running in the context of a user who is a local administrator, as far as another system is concerned, you can do things, right? Well, now we're going to talk about how that works. And we're going to talk about access tokens, which is the heart of this whole thing. We're going to talk about credentials, password hashes, and Kerberos tickets. When you're on a Windows system and you try to interact with another Windows system, Windows will try to automatically authenticate to that system on your behalf and tell that system who you are. That's single sign-on. And it's in the mechanism in Windows that allows you to browse file shares without being prompted every single time you want to copy a file or go into a folder. It's the mechanism that allows us to share printers. It's the mechanism that allows us to transparently authenticate to a proxy from a system joined to the domain. So single sign-on has a lot of convenience benefits. The heart of single sign-on is the access token. Access tokens are managed by the LSAS process in Windows, and LSAS is the security broker on a Windows system. They're created after logon. Access tokens are associated with each process, and each thread in a process may have a different access token from the process. Access tokens contain information about what rights the user the token represents have on the current system, and it also contains references to that user's credentials in many different forms. And this reference to these credentials is what enables single sign-on in a Windows environment. Now, if you have a beacon running in an administrator context, you can take advantage of token stealing to impersonate the rights of another process that's running on a system. Okay, here's how you do that. Use PS to list processes. And if you want to take on the rights of another user, use steal token, that process ID. And you will now be running with that access token. And if you try to interact with a remote resource, Windows will use the information in that token to negotiate and authenticate with the remote system. And if that token happens to have information that is seen as a local administrator on that other system, then you're in effect a local admin and you can do things. Now, to find out which token you have, type getUID to find out your user context. And if you want to drop a token, just do rev to self, and that will drop the token for you. Let's go ahead and do our first trust relationship demo. For these demos, I'm going to work from the system level beacon on the Climber system. And let's just be clear that our this beacon has no permissions anywhere because it's running as system. Okay? Can't do anything to the file server, can't do anything to the domain controller. So if we want to take on some rights, one way to do so is steal them from another process. So let's do a PS, and we can see there's processes running as JSmith, go figure. And there's also a process running as administrator. Why MS Paint? I have no idea. Either way. Let's go ahead and steal a token from process 2944. That's the Playland administrator account. Now, let's see if we have rights on the domain controller. We do. And let's see if we have rights on the file server. Big surprise, we do. Cool. And if we do a get UID, we can see that we are the administrator for the Playland domain. And if we want to, we can drop that token with rev to self. And now we're a nobody. We don't have any special rights. Okay? So that's an example of token stealing. Now, let's talk about credentials. If you're in a privileged context, you can use make token in Beacon to create an access token from credentials. Just do make token, domain /user, and the password. That's it. Okay? If you want to interact with a local account on a remote system, do make token period instead of domain /user and the password. Again, simple as that. Now, the problem with make token is much like steal token is it requires you to be in an administrator context before you can actually do anything with that token. So what happens if you're in an unprivileged context and you want to create a trust with a system? Well, you have a few options. One, you can use spawn as to kick off a process as that user. That would be my preferred method, okay? But you can also just use net use on the command line to establish a trust relationship with that system. So net use // host $C /user : domain user password. Okay, let's take a look at using credentials to make a token. Previously, we were able to collect the domain administrator's password using Mimikatz, right? It's Waza1234 ! So let's go ahead and try to make a token with those credentials. Let's just do Playland /administrator and then paste in the password, and there we go. Now when you use make token, what it does is it creates a copy of your existing token and modifies the single sign-on information to pass the credentials we specify. This is actually native Windows calls to do this. It's nothing too special. But that's why you're seeing that we're impersonating NT Authority system. Because on the local system, we're still the same person. It's just when we interact with the target, we're somebody else. So if we do a dir on the file server, you can see that we are who we claim to be. Or let's do invoke command -computer name DC, and we'll just do a who am I over winrm, and you see Playland administrator. So the token we made with make token works. I'm going to go ahead and drop the token, so we're back to being nobody special. What about pass the hash? This is a good one. So Beacon uses Mimikatz to pass the hash. The syntax is pth domain /user ntlm hash. You can do a local account as well. Just specify the computer name or a period instead of the domain name. Okay? Now you may be asking, what does this do? How does it work? Well, Mimikatz starts up a process with an access token whose single sign-on information is populated with the username, domain, and password hash that you provide. Cobalt Strike's Beacon then automatically steals a token from that process and shuts it down. So in effect, what you end up with is a token in your beacon that will pass that password hash when it tries to authenticate to a resource on the current Windows network. Okay, let's take a look at using pass the hash to set up a trust. What we're going to do is try to pass the hash with a local account, and that's only going to work if the SID 500 account is the same between systems, if it has the same password. And that's due to a patch applied to Windows 7 in 2014. So let's go ahead and try this with a local account. We could do pass the hash with a domain account if the hash is for a user who is a domain user who's a local admin on another system. That works as well. But let's go ahead and now just do pass the hash. And we'll do dot for the meaning a local account. Let's grab the NTLM hash and press enter. And there we go. We've spawned a process with Mimikatz and stolen a token from it. Now let's see if that token works. Let's just do a dir. Doesn't work on the DC. Let's see if it works on the file server, and it does. So we're able to pass this local administrator account's password hash to interrogate the file server. Let's talk about Kerberos tickets. Kerberos is a little bit different. Where the previous two techniques, pass the hash and using credentials, both boil down to creating an access token, Kerberos tickets are stored in something called the Kerberos tray. If you want to take a look at the contents of your Kerberos tray, type shell space klist inside a beacon. Okay? If you want to purge the current tickets that are in your Kerberos tray, just do Kerberos underscore ticket underscore purge. And if you want to load a ticket in a beacon, just do Kerberos underscore ticket underscore use. Now you may be asking, what is this Kerberos stuff, Raf? What are you talking about? Well, let me explain very briefly. Kerberos is a mechanism where you can prove to a broker called the Key Distribution Center Service that you are who you are, and the Key Distribution Center Service issues a ticket. You may now use that ticket to one time interact with a service and say, hey, service, I'm good. Here's my ticket granting ticket. Go verify it with that trusted broker and give me a service ticket that allows me to keep interacting with you without creating any burden on anybody else. If you capture one of these tickets or generate one, then you have the ability to interact with that service as whichever user is specified in the ticket. One place I use Kerberos to good effect is golden tickets, okay? A golden ticket is a self-generated Kerberos ticket with domain administrator rights. To forge a golden ticket with Mimikatz, you need 4 pieces of information. 1, you need to know the domain you want to forge a ticket for, okay? Next, you need the username of a domain administrator user. It has to be an active account, okay? Something that's enabled. Next, you need the domain SID they're going to forge a ticket for. And you can get this by typing shell whoami/user in a command shell, or in beacon, excuse me, and dropping the last numbers from that string that you get back. That's your domain SID. Those 3 pieces of information are available as any user on the domain. You don't need any kind of privileged context. The last piece you do need, though, is the NTLM hash of the KERB-TGT user from a domain controller. The KERB-TGT user is a disabled account, and it's the Kerberos ticket granting ticket user. That NTLM hash of the KERB-TGT user is the secret that security of Kerberos in a Windows environment depends on, okay? So if you capture that KERB-TGT hash, you can forge your own tickets and present those tickets to other services, and they'll give you service tickets that allow you to interact with that service as that user. Cobalt Strike makes it easy to generate a golden ticket. Just right-click on a beacon, go to Access, Golden Ticket. Put in the username you want to create a golden ticket for, the domain SID, and the NTLM hash of that KERB-TGT user. Press Build, and Cobalt Strike will use Mimikatz to both build the ticket and inject it into memory on a target. You do not have to be an admin on a target to do this. Okay, let's take a look at generating a Kerberos golden ticket. Okay? First, let's take a look at my Kerberos tray. And because we're in a 64-bit payload, or excuse me, 32-bit payload on a 64-bit system, we'll do C Windows Sys Native. And all these Kerberos tickets are as the JSmith user. Okay, fine. To generate a golden ticket with Cobalt Strike, just go to Access, Golden Ticket. And we need to provide these 4 pieces of information. Well, we know that the administrator account is active in Playland. We know that the domain name is Playland. We need the domain SID. So let's just do a whoami /user. And this value here is the domain SID for Playland. So let's just go ahead and grab that. Now we need the KERB-TGT hash from the domain controller. That's something that has to come from a previous compromise of the domain controller. So let's go over to this team server and look at the credential store. And these are the hashes dumped from a previous adventure. So let's press copy to put the KERB-TGT hash in the clipboard. Come back over here. And let's go ahead and paste in that KERB hash, but without the other pieces. And there we go. Press build, and Cobalt Strike will ask Mimikatz to create a golden ticket and inject it into memory. And better, we'll make sure that the ticket is only actually valid for 8 hours and allows itself, and it's allowed to renew, I think, for up to 1 week. So let's look at our Kerberos tray now with a K-list. And you can see we have a Kerberos ticket granting ticket here for the administrator user. So now let's just go ahead and try to talk to the DC and see if it works. And it did. So that's an example of using a Kerberos golden ticket to establish a trust relationship inside of a Windows network. Okay, let's talk about code execution. I'm going to show you code execution 2 different ways. We're going to do it first using built-in commands in Windows, and then I'm going to show you Beacon's automation to do it without touching disk. But let's start by doing it the native way. Here's the 4-step process to get code execution on a Windows system. Okay? Step 1, establish a trust relationship with a target. I showed you how to do that with stealing tokens, making tokens with credentials, pass the hash, and how to ingest Kerberos tickets as well. Next, you're going to want to generate an artifact and copy it over to the target. Okay? Next, you're going to want to run that artifact on the target. And finally, you're going to want to assume control of that artifact. Let's go through these steps. First, to generate an executable. For your lateral movement needs, I really recommend using the SMB beacon. That's the beacon that you can use to chain beacons together so they egress through a parent beacon. SMB beacon is phenomenal for lateral movement. So just go to Text, Packages, Windows Executable to export a stageless SMB beacon in a wide variety of formats. Now, to copy that executable you export, just use the upload command to upload the file you generated to the pivot host and copy that uploaded file over to the target using the copy command available in the shell. Not too scary so far, right? Now, let's talk about a couple of different ways we can use to run this executable. One of my favorite options is to create a service. This method requires that the executable you generate is a service executable. So pay very close attention to that because a plain executable will not run properly. So once you copy a service executable over to the target, all you need to do is create a service that references the executable you copied. So just do shell sc // target, create name, bin path equal. Very important, don't forget a space. C:\Windows, temp, wherever you put the executable. Okay? Now you can go ahead and start the service on target host with just sc // target start and the service name. Very cool. And if you want to clean that up, just do sc // target, delete, and the service name. That's how you kick off an executable using the Service Control Manager in Windows. Okay, let's do some lateral movement. Here we are in the JSmith beacon. No special trust. I got rid of all the stuff we did previously. We know from our previous efforts that JSmith is a local administrator on the file server. So let's just do a dir on the file server to verify that. Pretty cool. Okay, cool. So let's go ahead and take the file server. Let's first export a stageless Windows executable with the SMB beacon in it. And we'll do a Windows service executable. And we'll call it lateral.exe. Next, let's go to a folder we know we can write to. JSmith downloads. And let's go ahead and upload our lateral.exe and copy it over to the target. Okay? So all we're going to do is copy lateral.exe over to the file server, C Windows temp. Okay? Let's go ahead and create a service on the file server to run our lateral.exe. So we'll just do create lateral bin path equals C Windows temp lateral.exe. And let's go ahead and start the lateral service. We're just waiting for an acknowledgement that our service was indeed created for us. So that might take a moment. There we go. Let's go ahead and start up the service. Now, when I'm doing pivoting in this way, moving around a network and chaining beacons together, it's definitely my preference to live here in the pivot graph. So this is where we're going to be. So now we're waiting for acknowledgement that our service was started. So let's go ahead and link to the file server and assume control of that beacon that is running there. And there we go. We've now taken the file server by doing our lateral movement by hand. Last step, let's just go ahead and clean up. Let's delete lateral.exe off this system. And unless we're going to use it again on the other target, good idea to delete it off the other target too. So let's just do a dir or del C Windows temp lateral.exe. We can do this cleanup because beacon service executables, or excuse me, Cobalt Strike's service executables automatically migrate for us. So all we're doing is deleting that file and getting rid of our service as well. Cleaning up is definitely good tradecraft and good professionalism as well. Let's go through another technique. This one uses @. To use @ to run an executable, first generate a Windows executable, plain executable, and upload it to the target and know where it's at. And then next, find out the time on the target system. Just do net time // target. Next, use @ to ask your executable to run in the future. Just do @ // target, tell it a time in the future relative to the target, and the path to the executable on the target. Okay, presumably we've gone as far as we can with JSmith, so let's use @ to try to take the DC from the file server. Let's interact with this beacon and do a PS and see if there are any processes running as interesting users. And looks pretty cool. Explorer.exe. Let's go ahead and steal a token from that process. And we've now impersonated the administrator user, the domain administrator. Let's verify that we can hit the DC. And the answer is yes, we can. Cool. All right, let's go ahead and use @ to push an executable over. First, let's generate that executable. Windows executable, stageless. We'll do an SMB beacon as a plain Windows executable, and we'll call it demo.exe. Why not? And let's go to cd c windows temp, upload demo.exe, and let's copy demo.exe, not to the file server, but instead over to the domain controller. Let's do a net time on the domain controller. And let's schedule our executable to run at 10:55 p.m. So C Windows temp, demo.exe. So we've added a new job to that system. And now we've got to kill about a good 40 seconds or so until the job actually kicks off. Okay, let's do a net time again. And we can see that our job did kick off, probably. So let's go ahead and link to the DC. And there we go. We just took the DC with an @ job. So that's an example of lateral movement with @. Okay, let's talk about beacons automation. The downside to the previous two approaches is that they require you to put something on disk. And most red teams I work with are rather allergic to the whole concept. Okay? So Beacon has automation to help. First, you can use psexec in Beacon. Just type psexec target, a share, like $, admin$, and a listener name. And Beacon will generate a service executable, copy it over to that share, create a service to run it, stop that service, delete it, and clean up the executable. Okay? I put this old school psexec in place for situations where you're dealing with Windows XP systems. Beacon does have psexec PowerShell, and this will create a service that runs a PowerShell one-liner that gets your payload stager into memory. Okay? psexec PowerShell is pretty nice. It doesn't touch disk. That's pretty handy. The downside to services, of course, is it does create a log entry with the command that was run. You can use WinRM to kick off a PowerShell one-liner. Just do WinRM, the target name, and the listener you want to run. And Beacon will attempt to spread laterally that way. And you can do WMI, the target, and a listener. And Beacon will try to use WMI to kick off a PowerShell one-liner on a remote host as well. Okay? The WinRM and WMI options do not touch disk either. Now, one thing to note about WinRM and WMI is you will be in a restricted token. You'll be running as the user whose trust relationship got you onto that system, okay? But if you try to interact with another system from that new system you've gained, from that access token, it will not work. This is called the double hop problem. It's well understood by Windows administrators. The solution to it is to use make token to create a new token on the new system, or inject Beacon into another process. Now, let's go a little bit further with Beacon's automation. I've shown you how to do a lot of things by hand. Beacon does have automation to put all of this together for you. If you go to Cobalt Strike's target view, you can right-click on a host and go to Login, choose your favorite method, and you get a nice dialog that looks like this, okay? You can choose credentials, either hashes or credentials, and you can pick a listener and pick a session, and what Cobalt Strike will do is it will set up the trust with those credentials or that password hash, and it will use the lateral movement technique you selected to execute whatever beacon payload you requested on that target. And it will do that from the session you selected. If you don't want to create a new token, just check the box that says Use Current Session's Access Token. That's fine as well. Okay, now that I've shown you how to do lateral movement by hand, let's try it out with Beacon's automation. Here we are in a new network with a new foothold. one that's a little bit bigger, although I will caution you, it is an older test lab. But the benefit is it's bigger. So let's go over to the targets view. And let's go to What a Hog, Explore, and run NetView to find out some of the targets available to us. Okay? And there we go. Now, that's not a bad start. Now, let's get the help of a little bit of automation to find out where we might be a local admin. So let's go to PowerView PS1, PowerShell, invoke, find local admin access. Okay. So away we go with PowerShell, looking for where on these systems we might be a local admin. And that's going to be our first jumping point. And there we go. We have our winner, and that is the file server. So let's try to take over the file server. Let's just go right click, login. We'll do psexec because this is a older system. You can see by the icon. Let's do psexec, and we're going to deliver the SMB beacon. We need to choose a session to work from, and there's only one right now, so hit choose. And we're not going to use any creds or hashes right now. We're just going to use the session's current token. Hit launch, and that will launch beacons psexec against target. And there we go. We've now taken over the file server, and we have a beacon running as system. Okay, let's go to Explore, process list, and see what might be running as whom. Sort by name, and we see administrators logged in. Pretty cool, right? Let's go ahead and steal that token. And presumably, this beacon now has an administrator token. So let's go ahead and try to take a few more boxes. And by a few more boxes, I mean everything else. So let's just go ahead and push Control-Alt, highlight the systems we want, go login. We'll just do psexec since we're dealing with a mix of operating systems here. And what we're going to do is SMB beacon, choose the session to fire from, and that's the file server here because it has the token we want. Hit choose, and we're going to use that session's current access token. Hit launch, and there we go. We've just launched Beacon's or Cobalt Strike's automation against those different targets. And in a few moments here, we should start seeing accesses come in. Okay? Cool. Now, if you want to know what this looks like, jump over to the handy pivot graph, and now you can see what our access into this network looks like. Okay? Layout, tree, top. There's our foothold. There's the first system we took, and then there's the other systems we were able to take from there. Okay. That was a lot of material, but you gotta admit, it's pretty cool stuff. We talked about the Windows Enterprise. I took you through host and user enumeration. We talked about how to interrogate and control a system without malware. I took you through how to set up trust relationships by stealing tokens, using credentials, using password hashes, and ingesting Kerberos tickets. I also showed you a few ways to get remote code execution using Beacon. This concludes part 6 of Advanced Threat Tactics.